Think about your laptop right now. You might have a high-definition video streaming, your email client downloading new messages, and a chat application pinging you with texts, all at the same time. This diagram shows a single data pipe delivering all that information to your laptop. Your IP address ensures the data reaches the correct physical machine. But once it arrives, that address has no mechanism to sort this jumbled mix of video, text, and email. To solve this routing problem, your system relies on ports. Think of your IP address as the main street address of an apartment building. Ports are the numbered apartment doors inside. They dictate exactly which application receives each piece of arriving data. For everyday traffic, the internet uses standardized doorways. Unsecured web traffic, HTTP, is routed to port 80. Secure web traffic, HTTPS, goes to port 443, and domain name system requests, or DNS, use port 53. Without these numerical endpoints, our devices would receive a chaotic pile of untargeted data, making modern multitasking impossible. There is a distinction between a port and a service. While the port is the doorway, a service is the application or function operating past that doorway, like a web server processing incoming requests. A computer doesn't just manage a few of these connections. Modern network architecture provides a single system with tens of thousands of available endpoints. This spectrum breaks down 65,535 ports into 3 zones: well-known up to 1,023, registered up to 49,151, and dynamic up to 65,535. Test your recall. Which port loads a secure banking website? Answer: port 443. Communication relies on these universally standard numbers. This organized numerical grid allows the internet to communicate predictably without requiring any prior coordination between the client and the server. Now we examine this exact same architecture through the lens of a malicious actor. Every open port acts as a potential entry point. If the service behind that doorway has a vulnerability, the network is compromised. To find these, attackers use a port scanner. It maps these doorways, sending a probe to identify unguarded services. The defensive rule is simple. If a service isn't required, its corresponding port must be closed. Identifying and mapping these active ports defines a system's attack surface. Let's track a complete data request. When you load a web page, your web browser assigns itself a temporary high-number dynamic port, like 50,000, to initiate the connection. This request travels across the network and docks into the server's well-known port 443, reaching the web service inside. Here is the summary of the core rules. A port is the numerical doorway, while a service is the application inside. The standard everyday ports are 80 for HTTP, 443 for HTTPS, and 53 for DNS. Finally, secure network management requires closing any unused ports. Memorize these core ports, then research how to audit open ports on your operating system. Now that you can identify the network stores, the next step is learning how to deploy the security guards to protect them. Next, we cover the basics of firewalls.